Here I use lost sales file from JMP to run logistic regression model. First, I will start with simple logistic regression. Under fit y by x platform, status will go to response, code, time to delivery. Here I send part type, which is a categorical variable as well, to factor so that I will create a contingency analysis for that factor too. Simple logistic regression models for code and delivery, plus the part type. To use color for differentiation of two areas of lost and won, I will right-click on one of these graphs, row legend, select status. Two colors will be applied, lost and won, red and blue. You can better see the area of won and lost in these two graphs. In this area, we see code on the horizontal axis and then two vertical axes. On the right side, we can see lost and won. The entire area is divided in two sections because we do have a two-level categorical response. And this area is divided equally. On the left side, we have the status. The number starts from 0 to 1. This is actually the probability, the likelihood of belonging to one of these two areas, won or lost. And the line in the middle divides the entire area of probability between lost and won. So those observations, won, the codes are on the upper side, blue, lost on the lower side. So is for time to delivery. Just the slope of the line separating these two areas here shows that time to delivery is more sensitive. Because if you consider any of those points, the blue points, if you add to the time of the delivery, that means moving that point to the right on a horizontal line, then it will pass that line, the separating line, easily going to the red area. While the almost flat line for the code, we have to move any of those blue lines a long way in order to get into the red area. So move down to the model test. Whole model test, probability greater than chi-square. This is in fact the p-value of the entire model. The likelihood ratio is similar to chi-square, so a chi-square test is used for the test of significance for the model. P-value of 0.528 shows no significance of code factor for predicting status. On the other side, time to delivery, very small p-value. That means this is a significant model. The R-squares calculated for both models, still small but much larger than that of code. Misclassification rates, important numbers to know. Here it is close to 41% for time to delivery and about 49% for code. And that 49% means almost random, because if we have a two-level outcome, any random factor, we expect that with no relationship to the response comes out as 50-50. So if misclassification rate is 49%, that means it's almost completely random. And then parameter estimates. Here again, we can see chi-square test is used for the significance of the numbers obtained for the intercept and coefficient of code. None of them are significant, very large p-values. For time to delivery, both p-values are very small. So time to delivery in a simple regression model is a significant predictor of the outcome. Now we get into contingency, relationship of two categorical variables, part type and status. On the right side, you will see the legend dividing the area into two equal portions. On the horizontal axis, we can see original, equipment, and aftermarket. The horizontal axis is divided proportional to the count of original and aftermarket codes. Lost and won on vertical, it's divided equally, and the status is similar to logistic regression, vertical axis on the left side from 0 to 1. You can see the difference of proportions. In aftermarket, the proportion of the blue, the bone, is more than the red, the lost. In original equipment, proportion of blue is less than red. And that's something we can see in contingency table too. These four indicators explain the four numbers we see in each cell. For example, aftermarket and lost. Count the total 183. That means 183 codes went out for aftermarket and lost. Next cell, 212 codes went out for aftermarket and wound. The total of them will be 395. Then second, total percentage. Those aftermarket codes that went out and lost are 33.27% of total. Column percentage, that means percentage of all lost codes, including aftermarket and original equipment, 67%, and row percentage, 46%. 46% of the aftermarkets were lost and 53.67% won. In a similar way, we can read the numbers in this table. Total of 550 codes. Percentage of the lost, 49.45, and percentage of won, total 50.55%. We can add or reduce the numbers to this contingency table. From this drop down, we can see elements of chi-square, the expected, and cell chi-square. If you add them, you can see all those elements of chi-square test right here. Here is how the chi-square of a cell is calculated. For example, for the lost codes for aftermarket, 395 codes sent out for aftermarket. If there is no difference between aftermarket and original equipment, we know that from 550, 272 codes were lost. So the same proportion should be lost out of 395. The ratio of these two, 272 over 550, is 49.45%. So if you multiply 395 by this percentage, 49.45%, you will get the expected loss. The expected codes for aftermarket loss should be 195.345. So plug it into the chi-square formula. The difference of observed and expected, 183 and 195.345. Square this number and divide it by expected, 195.345. And that will be the chi-square, 0.7802. Try these numbers, you'll get exactly the same result. Now, for four cells here, for this contingency table, we have four numbers as chi-squares of cells. The chi-square for the entire table, is the sum of all these four numbers. You add them up all, will be 5.477. Same number got here as Pearson chi-square. And then degree of freedom for a contingency table, it will be the number of rows minus 1 times the number of columns minus 1. We have 2 rows, 2 columns, so it will be 1 by 1, so degree of freedom 1. If you go to chi-square table, you will find the significance level. To calculate the chi-square using Excel or in JMP, you will find a very small p-value. So the result shows that part type is a significant predictor of the outcome, the status of the code. To get the estimation, I will go to Logistic Regression for time to delivery. From that drop-down, save probability formula. It will save the outcome, estimate of the outcome, to our table. Going back to the data table, 4 columns are saved. Log linear of loss, probability of the loss, and probability of won for each one of those rows based on the formula that is created through logistic regression, and most likely status. If the probability of won is more than 50%, outcome is won. If probability of loss is more than 50%, the outcome is lost. Adding these two probabilities, the result should be 1 or 100%. That misclassification rate is the rate of all those cases where, for example, the actual status is won and the outcome by formula is lost, or vice versa. Now we scroll down in the first blank row. Since our formula is based on the value of just one variable, time to delivery, you can enter a value in this blank cell, for example, promising 30 days for delivery. The results will reflect that number. The expected outcome will be won.